Now next point is about geometric progression. AP we have discussed. Fine. Now let's consider these two progressions or sequences. Consider like this 2, 4, 6, 8 and so on. Now here clearly you can see that the difference between any two successive terms is constant. So this is an arithmetic progression. You know, a sequence is said to be AP if difference between two successive terms is constant. What is difference of these two? Here 2. What is difference? 2. So we can say that the D equals to 2 here. So such a sequence or progression is called AP. Now consider this. Let's consider this. You see 1, then 2, then 4, then 8, then 16 and so on. Now this is not an AP because here difference is 1. 2 minus 1 is 1. 4 minus 2 is 2. So is not an AP. This is not an arithmetic progression. This is not an AP. But if you see the ratio of two terms, any two terms, ratio of two successive terms, if we see this, that is 2 by 1, which is 2, then 4 by 2, which is also 2, then 8 by 4, which is also 2. So here ratio of any two successive terms is constant. What? Ratio of any two successive terms is constant, and this sometimes denoted by here small r. So small r is 2 here. So such a progression or such a sequence is called a geometric sequence. So this is a geometric sequence or progression. In short, we call that as GP. So what is the definition of geometric progression? Where the ratio is constant. A sequence in which ratio of two successive terms. There we were looking for differences. Here we are looking for ratio of two successive terms is constant, then it is called GP. It is called geometric progression. It is known as which progression? Geometric progression. Ratio of any two successive terms, is constant. It has to be usually non-zero constant, but in general constant. If it is 0, then all terms will be 0. This is known as a GP. So this is one example of a geometric progression. Fine. You can have these also, like if I write 1, then 1 by 2, then 1 by 4, then 1 by 8 and so on, is a geometric progression. This is also a GP. It's not an AP. So how do you define? Ratio of any two successive terms is constant, then it is called which progression? Geometric progression. Now we want to write the formula for an NSN for a geometric progression. So let's take the first term equals to, as we did in case of AP, first term equals to small a, and ratio, which is sometimes called the common ratio, equals to small r. So here A1 is A. What is A2? Second term of the progression, that is A into R. There we were adding the common difference. Here we need to multiply the common ratio. So these upon this gives us R. What is the third term here? That is again multiply with the common ratio, that is AR square. Then A4. What is A4? That is AR cube, and so on. If you have one term, you multiply with the common ratio, so you'll get the next term. Again multiply with the common ratio, you'll get the next term, and so on. In AP, you were adding the common difference. Fine. So from this nth term, you can see in third term you have r square, in fourth term you have r cube. So in the nth term you must have a into r raised to n minus 1. This is the formula for which term? Nth term. Nth term of which progression? geometric progression. A into r raised to n minus 1. What's the formula for nth term? A into r raised to n minus 1 for a geometric progression. Put 2, second term. So if I put 2, a r, you will get this. Put 3 here, third term, a r square. So this is nth term formula for a geometric progression. Fine. Now we want to add all this. So next one is Sn, that is a1 plus a2 and so on up to n. Sum of the n terms. This is the nth term of the corresponding series. Now I'm just stating this one without proof. A into r raised to n minus 1 upon r minus 1. This is the formula for which progression? Geometric progression for summation of how many terms? N terms. R should not be 1 here. Otherwise this becomes 0, you know. What is the formula? I wrote without proof, remember. If you are interested, you can just refer the textbook, but proof is not anyway important for you. Sum of the n terms of a geometric progression Sn. What is that? That is a into r raised to n minus 1 upon r minus 1. Sum of the n terms of a geometric progression, which is given by this. Sometimes even you can write like this also. A, you take minus common from both of this. So you can write 1 minus r raised to n upon 1 minus r. Both are same, remember. The only difference is what from this you took minus common, from this minus common, and you cancelled it. Both are same. You can use this or this. Right? That's not important. Fine. Freely any one of these two can be used. But you need to remember this formula, right? Every question of geometric progression in the next exercise you can solve using this or both, like AP questions. So far we had these 4 formulas. One is for nth term of an AP. So for AP you have this. What is that? An equals to a plus n minus 1 into d. For geometric progression it is this. And for AP what is Sn? It is n by 2 into 1 is a plus l, and the other one is nothing but what? N by 2. Here n by 2, 2a, n by 2, 2a plus n minus 1 into d. This for arithmetic progression. We know it, just I'm reminding you. In every AP question either you solved using this or both. And every GP question will be solving, you will see either using this or both, or you can use these also. Both are same as I told you. So this is about geometric progression. Now, as we were discussed in AP, we want to write geometric mean, that is GM. AM we have discussed. So the next one, that is about geometric mean. Geometric mean, that is nothing but what? GM, geometric mean. AM we have discussed, right? If you remember, arithmetic mean we have discussed. Okay, so what we do, we take 3 numbers. Let A, I'll write capital G, and B, let these 3 numbers be in geometric progression in GP. These 3 numbers be in GP. Then the middle number, the G, is called geometric mean of the other 2 numbers, A and B. If 3 numbers are in geometric progression, then the middle number, this one is called geometric mean of the other 2 numbers. So therefore here, these upon this, if you do ratio, this upon this, G by A equals to this by this, that is B by G. So from this what we'll get? G squared equals to AB, and therefore we can write positive square root, that is G equals to root AB. So this is nothing but the formula for geometric mean. Geometric mean is given by what? Root AB. G is given by what? Root AB. That's the geometric mean of these 2 numbers. Like this, for example, geometric mean of, let me write 2 and 8 is G equals to root of 2 into 8, which will be 16. So we write here positive square root, which is 4. You can check that 2, 4 and 8 are in geometric progression. That is 2, 4 and 8 are in which progression? Are in GP. As we are discussed, this is exactly same as what you did in case of AP. So this middle number, this become geometric mean of these two. And how do we get that? By this formula. G square equals to AB or G equals to root AB. Fine. Clear? Up to this, G equals to, we have this. Okay, so here one. You just recall for arithmetic mean. If you remember, AM is given by A plus B by 2. This was the formula for arithmetic mean. Arithmetic mean was just the average, A plus B by 2. Here it is root AB, product and then take the square root. Fine. Now, again, as we did there in case of AP, we generalize this concept. So take two numbers. Let's take these two numbers A and B, be these two numbers. Between these two numbers we put n numbers. So I'll call that as G1, G2 and so on Gn. Here you had placed how many numbers? Just one number. Here you have placed how many numbers? N numbers. These are the n numbers. So now total it will be n plus 2 numbers is a geometric progression. We put these numbers between these two A and B. We put this number, so total numbers forms which progression? Geometric progression. Then these numbers are called n geometric means. N geometric means between A and B. Between A and B. We put these numbers, n numbers, in such a way that these are called n geometric means between A and B. Fine. Now the question is how to get this G1, G2 and so on. So as we did there, just recall that to get this G1, you have the first term. So what you need to find? Common ratio. If I have first term and the common ratio, I can get the G1. So here it can be derived. I'm not writing that proof, but I'll write just a formula. Common ratio R in this case, it is given by, without proof, B by A raised to nth root of n plus 1. That is raised to 1 upon n plus 1. N plus 1. This is the formula. There what was the formula? Let's recall that. The formula there, it was, if you remember, D equals to B minus A upon n plus 1. For AP I'm just telling you. For AP it was this formula. Can you recall that? D equals to B minus A upon n plus 1. Here for the common ratio, what's the formula? B by A. Instead of subtraction you have division. Instead of upon you have root, nth root, 1 upon n plus 1. So once you get R from this, you know A. So what is the G1? Therefore G1 will be A into R. Fine. Once you know this G1, then what will be the G2? That is the previous term into R. So it will be AR square and so on. Right. So you can get these n numbers between these two. I hope this is clear to you because it is just similar to what we did in case of AP. Okay. Now I'll take a simple example just to illustrate this. So let's see one example here. For example, the question is insert, this is a question, insert three numbers between 1 and 256. This is a question. Such that the sequence is a geometric progression, right? So what is asked indirectly here? Between these two numbers 1 and 256. These are the given two numbers. As per our language, this is A, this is B. You want to insert how many numbers? 3 numbers. That is asked. So 1, 2 and 3. So this become which progression? Geometric progression. So this is G1, this is G2 and this is G3. 3 numbers in such a way that these 5 numbers form geometric progression. Okay. So what you need to do? You need to get the R. Once you know R here, then you can get the g1 very easily. Okay, so here let's recall r, that is b by a raised to 1 upon n plus 1. Here how many numbers you are asked? 3. So here n is 3. So I'll just place the value. This is 256 raised by 1 raised to 1 upon 4. Fine. Now 256, you know, you can express in form of what? Here in power of 4, right? So here it would be, we know this is 2 raised to 8 in power of 2. So this is 2 raised to 8 raised to 1 by 4. So here you are just left with 2 squared, which is 4. So r is 4. So therefore, now you got the common ratio. What is G1? First term into common ratio, that is A into R. That is 1 into 4, it will be just 4. What is G2? That is A into R squared. Previous term into common ratio. So 4 into right R. So it will be 16. What is G3? That is previous term into 4. Right? So it will be how much? 64. So these are the 3 required numbers. Required numbers or required geometric means. Right. Next number, if you multiply with 4, you will get exactly this. Fine. I hope now this is clear to you. Exercise 9.3 now. First question. You are given geometric progression here. GP is 5 by 2, 5 by 4, 5 by 8 and so on. So immediately you can write the first term, which is 5 by 2. This is the first term. What is common ratio? These upon this. 5 by 4 upon 5 by 2. So 5 will get cancelled. That is just half. R equals to 1 by 2. Okay. Now what you want? You want first nth term. An equals to a into r raised to n minus 1. We know. What is a? 5 by 2. What is r? 1 by 2 raised to n minus 1. Here n minus 1 power, here 1 power. So 5 upon n minus 1 and 1. So it is 2 raised to n. That is nth term. Okay. And now you can answer 20th term very easily. Just put n is equal to 20. So what is a20? That is 5 upon 2 raised to 20. You can live like this because 2 raised to 20 is big number. You know 2 raised to 10 is 1024. So if you want, you can write 1024 into 1024. But you can leave it like this. Okay. We go to question number 2 here. Second question. What about that? Find the 12th term of a GP whose 8th term. So A8 you are given, which is 192 and common ratio is 2. What is asked? You are asked for 12th term, that is A12. That is what you are asked. 12th term of a geometric progression. So what you need to do to get this here, in every JP question you need to get A and R. What is A? What is R? Both the things you need to find. In AP we were finding A and D. So here we find A and R. R is already given to you. So just we need to get A. Okay, so write the formula for this. What's the formula for 8th term? That is A into R raised to 7 equals to 192. But A we know. What is A? That is 2. So we have R, I'm sorry. What is R? That is 2 raised to 7 equals to 192. So therefore A equals to 192 upon 2 raised to 7. Right? So let's simplify this. So here 64 into 3 and 64 into 2. So we'll get the 3 by 2. So A is 3 by 2. Now what is asked in the question? 12th term. That is a question. So A12 is equal to A into, R raised to n minus 1. That is R raised to 11. What is A? It is 3 by 2. Fine. What is R? R is 2. So this is 2 raised to 11. So if we simplify this, this is 3 by 2 into 2 into 2 raised to 10. So this will get cancelled. So what we'll get from this? Here you will get, very 2 raised to 10. I told you it is 1024 into 3. So if you do that, what will get? 3072. That is required value. Fine. The next question, for a geometric progression, 5th, 8th and 11th terms are P, Q and S respectively. So what is small p? It is A5, 5th term. What is small q? That is 8th term, A8. And what is S? That is A11. This for a geometric progression. Okay, let A1 equals to A and common ratio equals to small r. Let's take this. So what is small p here? Small p will be A into r raised to 4. What is small q? A into r raised to 7. What is small s? A into r raised to 10. We have these three things. Fine. Now we want to prove that expression, right? So I'll write to prove. What do you want to prove? Q square equals to r into s. So write LHS, that is q square. That is a square into r raised to 14. We are just squaring this. What is RHS? That is r into s. What is r? I'm sorry, this is PS. This is my mistake, not RS. So here PS. So what is P? P, you know, A into r raised to 4. What is S? A into r raised to 10. So we'll get the a square into, both bases are same, so you can add the exponent. So you can see this is 2, this is 1. So from 1 and 2, LHS equals to RHS. It's proved, right? That's what you wanted. So what you have used, basically you have used the formula for an here 3 times. An equals to a into r raised to n minus 1, and you have just placed the value. As I told you earlier, every question is based on those two formulas only. Fine. Next, 4th, I'm sure you can do it, not a big question for you, so try it yourselves. 4th one. Let's go to 5th question. In 5th, there are 3 sub questions. What is asked? Which term of the following sequence is, like the first one, 2, 2 root 2, 4 is 128, right? So what's the question? Find n for which nth term is 128. Read the question. Which term means an of the following sequences. Here for first one it's 128. So you want n for which nth term is 128. You are given a geometric progression, so you can write a and r very easily. What is a here? A is 2. What is common ratio? Term upon the previous term, which is root 2. A is 2, these upon this, which is root 2. So therefore, here if I use this, let me use this. What is a? A into r raised to n minus 1 equals to 128. I know a, I know r here. What is a? 2. What is r? Root 2. That is 2 raised to half. Root 2 means 2 raised to half. Raised to, you have n minus 1 equals to 128. Fine. Now here further you can simplify. So we have here 2 into, this is 2 raised to n minus 1 by 2. Power of the power gets multiplied. And 128 you can express in power of 2 very easily. What's that? That is nothing but, here it is how much? Yes, it is 2 raised to 7. So this is just 2 raised to 7. So both the bases are same, so you can add the exponent. 1 plus n minus 1 by 2 equals to 2 raised to 7. So this is 2 raised to, and if I just simplify, by 2 equals to 2 raised to 7. Bases are same, so I'll just compare the powers. N plus 1 by 2 equals to 7. So what is small n from this? It will be 13. So for 13th term, that is A13, gives us here 128. 13th term, n equals to 13. So 13th term will be 128. Fine. Same way you can try the other two questions. There B and C, same questions. Just use the formula and simplify. There's 2 more sub questions for you. Try it. Next, question number 6. I'll go to 6th question. What is asked in the 6th question? For what value of x these 3 numbers are in geometric progression? Minus 2 by 7, x and minus 7 by 2 are in JP. So ratio must be same. These upon this, minus 2 by 7 equals to these upon this, minus 7 by 2 by x. So you have here x squared equals to product of these two, which is just 1. Which formula? Even you could have used directly this one, g squared equals to ab. Also you could have used square of these equals to product of these two, right? That also you could have done. So therefore, what is x from this? Plus or minus 1. These numbers are in GP, so therefore this upon this equals to this upon this. So x square equals to 1, and therefore x equals to plus or minus 1. Question number 7 to 10 are about sum to indicated number of terms. That's a question. Okay, so from 7 to 10 you need to use just Sn for a geometric progression. So it is a into 1 minus r raised to n upon 1 minus r. This is what we are going to use for these 3-4 questions. So let's see the 7th. Your geometric progression, you are given 0.15, 0.015, 0.0015 and so on, right? You want S20. This is a question. Get S20. Sum of how many terms? 20 terms. So you need A and R, and then just we are going to place. What is A here? A, you know, it is nothing but the 0.15, first term. A is nothing but what? 0.15. What is R? That is a common ratio, term upon the previous term. Directly you can observe, if you divide by 10, you will get exactly this. Or if you cannot observe this, you can just write like this upon 0.15. And this, just you can notice, it will be 0.1 or 1 by 10. You multiply this by 0.1, you will get exactly this. You multiply this by 0.1, you will get exactly this. So R is this, A is this. Now we just place over here. So S20 equals to A into R raised to, okay, let me write 1 minus R raised to 20 upon 1 minus R. Fine. Now let's put the value. What is A? 0.15, that is 15 by 100. 1 minus R, what is R? 0.1, so 0.1 raised to 20 upon 1 minus 0.1, so this is just 0.9, and this will be 15 by 100 as it is here. 1 minus 0.1 raised to 20 we keep as it is, upon this is 9 by 10. This is 9 by 10. So here this would be how much? 1 0 will get cancelled. This is 15 by 90 into 1 minus 0.1 raised to 20. So this will be 1 by 6 into 1 minus 0.1 raised to 20. That is S20. Sum of the 20 terms of a geometric progression. This is just simplification, remember. The important one is up to this, putting the values. And once you are given a geometric progression, always you can get A and R very easily. I'll do one more from there. Let me do the 8th one here. So their geometric progression is here root 7, then root 21, then 3 root 27, and so on. This is a JP. What is the first term? Root 7. Fine. What is the R here? Let's try R. That this by this, root 21 upon root 7. So obviously it will be root 3. Multiply this by root 3, you will get this root 21. So R is root 3, first term is root 7. What is asked there? You are asked for Sn. Get the Sn. This is the question. So here we just write the formula and we place the value. Okay, so what is the Sn here? Sn equals to, we know a into r raised to n minus 1 upon r minus 1. What is a? Root 7. It is here. What is r? That is root 3 raised to n minus 1 upon root 3 minus 1. Right? Now normally you can keep in this form, but normally we never keep irrational number in the denominator. So what I'll do, I'll multiply and divide with the conjugate. So root 3 plus 1 upon root 3 plus 1. What we did? Multiplying and dividing by conjugate. You know this procedure from complex numbers. So what we'll get from this two? A minus b, a plus b, which is a square minus b square. So 3 minus 1, which is 2. Root 7 as it is. Here 3 raised to half. So it will be 3 raised to n by 2. Minus 1 into the other factor, which is root 3 plus 1. I just explained this. This means 3 raised to half and the whole raised to n. So what will be this? The product of this 2. That is 3 raised to n by 2. A minus b, a plus b. What is a minus b into a plus b, which is a square minus b square. So square of this, which is 3 minus 1 square. 3 minus 1, which is 2. So root 7 by 2 into root 3 plus 1 into 3 raised to n by 2 minus 1. This is Sn. Sum of the n terms of a geometric progression. Right? It's so simple, not a big task. So I'm sure you can do 9, 10th. So this question number 9 and 10 for you as an exercise. We'll go to question number 11 here. Question number 11. You are asked to evaluate the sigma k from 1 to 11, 2 plus 3 raised to k. Now the sigma you might have come across earlier. Otherwise, later on we'll see the sigma indicates summation. We know it. Okay. So I'll just take the sigma inside. So what I'll get? Sigma k here from 1 to 11, 2 plus sigma k runs from 1 to 11, 3 raised to k. Now what is the meaning of this? This means you take k equals to 1, but k is not there. So 2. When you take the next value, you need to put plus. Now I'll take k equals to 2, but that is again not, k is not there, so again 2. How many times you will do 2 plus 2 plus 2? That is 11 times. Because summation goes up to which number? 11. Right? So 2 plus 2 plus 2, 11 times, you know it is 22. 11 into 2 plus, now come to this. Here you will realize further what I am trying to tell you. Put k equals to 1. So what is this? 3 raised to 1. Sigma means plus. Put k equals to 2. So 3 square. Next, plus 3. So 3 cube. And so on till 3 raised to 11. I repeat what I did. Put k equals to 1. 3 raised to 1. Plus put k equals to 2. 3 squared. And so on. Which is the last number? 11. So we have this. You might have noticed this is a geometric progression where the first term is 3. What is the common ratio? This by this, which is also 3. This upon this, 3 square by 3. So this is a geometric progression having how many terms? 11 terms. N equals to 11. So this can be added. What is summation of the first one? That is 2, 2, 2. How many times? 11 times. Plus Here we use the formula for GP. Which formula? S11. This is simply sum of 11 terms of a geometric progression. So what is that? Let's write A into, let me write here r raised to 11 minus 1 upon r minus 1. Fine. So this is equals to 22 plus, what is A? That is 3. R, what is R? 3. 3 raised to 11 minus 1 upon R is 3. So this is 3 minus 1, which is 2. So here finally we are getting this 22 plus 3 by 2 into 3 raised to 11 is a big number. No need to place the value. You can leave like this. This is the required summation. Fine. This is obvious. 11 times 22. This is a geometric progression. First term is this, second term is this, third term is this, and this is 11 terms. So there are 11 terms. First term 3, common ratio is also 3. You want as 11. So this is answer to 11 term here. And the required summation is this, right? You are asked for this summation. Question number 12. There you are given that sum of the three terms, first three terms of a GP is 39 by 10. Sum of first three terms equals to 39 by 10 and product equals to 1. These two things we are given. What is asked? Find the common ratio and the terms. So what we do, let first three terms be this, first three terms be this. We select like this here, A by R, A and R, AR like this. You can see here common ratio is R. Multiply this by R, so you'll get this. Multiply this by R, you will get this. This is a very standard way of selecting three terms. If you selection of three terms, normally we select in this way. Okay, why we have chosen like this, you will realize as I do the question. So therefore their summation A by R plus A plus AR equals to 39 by 10. And this is one condition. And what is the other condition? Their product. That is A by R into A into AR equals to 1. Now you can see that here RR will get cancelled. So you will get the A cube equals to 1 and therefore A is 1. Therefore A is 1. So because of this we have chosen this way. The sum becomes a little bit easier. Now you have A, so you can put into the 1, so you'll get the value of R. So by 1, what we'll get? 1 upon R. Here this is 1, this is 1, this is 1. 1 upon R plus 1 plus R equals to 39 by 10. Fine. Now here we just simplify. So this is 10. Here 1 plus R squared equals to 39 upon R. I'll take on the other side. Now this is a quadratic equation. 10R squared plus 10R plus 10 equals to 39R. And therefore we have 10R squared. Take this one over here. So minus 29R plus 10 equals to 0. Now simplify factorization here. So 10R squared, 100, difference should be 29. So you can write 25R minus 4R, 29, and product is 100 plus 10 equals to here 0. This is simple factorization, we know it. So here what is common? You can find 5R common. So this is 2R minus 5 and you can find 2 common. So 2R minus 5 equals to 0. So what are the factors? 2R minus 5 and the other factor 5R minus 2 equals to 0. So therefore, we have two possible values of R. Either R is 5 by 2 from first factor or R is 2 by 5. These are the two factors, 5 by 2 or 2 by 5. Okay. Now terms are, we just place the value. Terms are, we are putting where? In the selected terms. You know A, you know now R. So what is, I'll take this first. A is 1. So 1 upon 5 by 2, then 1, and 1 into R, that is 5 by 2. So you will get the 2 by 5, 1 and 5 by 2. Right? 1 is this. Or what is the other possibility? Now we are choosing this 1 upon here 2 by 5, this is 1, and 1 into again 2 by 5. So this is 5 by 2, this is 1, and this is 2 by 5. These are the possible terms, either this or this, and A is 1.